All right, short late video for those who were not able to be in class when we talked about variation. Direct variation is when one thing is directly proportional to the other thing. So basically where we could just, sorry about the misspelling there, y is equal to some number times x. So you would just multiply some number times x, that would give you y. When you know, we'll look later about when you know three numbers and you're looking for a fourth, how we write that. If it was joint variation, when it says y varies, then we would go y equals, still be some number, and then this would just have two other variables. The k would be a constant, all right? So the k would be a constant, and then y is inversely proportional to x. In that case, there are a couple ways you could write this. You could write y is k divided by x. But how I like to write this one is that x times y is always equal to the same number. This just makes more sense to me, personally. But either way is acceptable. So on these ones about identifying the equations, by the way, we're not going to talk a whole lot about joint variation, so mostly about direct and inverse. If we're trying to determine which one it is, like think about like if you can get the y by itself, which one of those examples at the top does it look like? Remember, k is a constant, so k would be a number. So in number 1, that is, of course, direct. And the k is 2. In number 2, that looks like the right-hand side, right, where the x is in the bottom. K is 24, and that is inverse. Now, when you look at number 4, if you get the y by itself, it would say y equals x over 3. Now, sometimes people think, oh, that means it's inverse because I see a fraction. The inverse is only inverse because the x is in the bottom of the fraction. In this case, this is not inverse. This is the same thing as 1/3 x. So this is still direct. This is still direct. But k is 1/3. This would be joint. I know that because I see 3 different variables instead of just 2. K is 5. Number 5, see how x times y equals a number? This is inverse. And k is 36. And then this one that is a proportion, if I would cross multiply, I would get 5y is equal to 2x. And then when I get the y by itself, I have y is equal to 2/5 x. So k would be 2/5, and it is direct. All right, so I'm not going to really be asking you other than on the application problems that I made up. You are going to be choosing between direct or inverse, only those two. Direct, if one thing goes up, it makes sense that the other number would go up in the application. In inverse, if one thing would increase, the other one would have to decrease. So let's look about when we're looking for a missing number. And we'll also take a quick look at an IXL lesson. So some direct variation examples, and for these examples, if there are going to be 4 numbers involved. We know 3 out of the 4. We're looking for the 4th one. Direct variation, these are going to be proportional. When it says directly proportional, hopefully you have used proportions before, and this would be where we say the first y over the first x is going to equal the second y over the second x. And we fill in and we cross multiply to find the one that we don't know. So this says 28 when x is 7. That's my first y and my first x. Find x when y is 52. So I'm looking for this other x, and y is 52. Then I cross multiply, which gives me 28x is equal to 364. And then when we divide, x is 13. And you may just know that, like maybe you don't usually write an equation, just the 2 that are diagonal, that are both numbers, get multiplied, and then they get divided by the guy whose diagonal partner is the x. We will not be looking at one of these that talks about directly proportional and square, so we're just going to ignore number 10. And then number 11, the dollar amount that she earns varies directly with the number of hours she works. That's very much the same for most of us. Not me, because I'm on a salary, but if you're working and you get paid by the hour, it varies directly. So the dollar amount is, that's the D in this case, is like, so this is like D over H has to be equal to D over H. It's a direct proportion. So her first dollar amount, $148.50. She made that working 18 hours. So what would she make? She made $90.75. We don't know how many hours. And then we cross multiply and divide. And if my memory serves me correctly, I believe this was 11 hours. You could also find out how much she's making per 1 hour by dividing, and then divide that number into 90.75 to find out how many hours she would need to work to make the $90.75. All right, so those are direct proportions. Other examples that would be direct proportion or direct variation. So that talked about like the money earned versus, so like gas used and miles driven. If I drive more, I'm going to use more gas. All right, so the amount of an ingredient in a recipe and the number of servings. If I want to make more, I'm going to need more proportionally, right? You wouldn't just add 2 cups to both, you would multiply proportionally depending on. All right, so those are a couple other examples that would be using direct variation, also known as direct proportion. We're skipping over the part about combined, or joint, Well, we're skipping over the combined part to it too. But we're going to look next at inverse variation. And inverse variation, remember I said how I like to write it as x times y equals a number, right? X times y equals k. And so if I have 2 different sets of x and y, then what I'm saying is my first x and my first y multiplied together have to give me the same answer as my second x times my second y. So x1, y1 has to equal x2, y2. And when they're written right next to each other, so that means multiply. So, and it doesn't matter which one I write first, honestly. So in this question number 13, it says if it is inversely proportional, all right, so 7.5 times 8 has to equal 5 times x. So the x and y in the first situation has to equal the x times the y in the second situation. So then I multiply, I get 60 is equal to 5x. I solve for x. X is 12, because 12 times 5 is also 60. We're not going to mix up with this, we're not going to do this one. I will put something else up there in just a moment that you can write down as an example. So here, he's driving to Disney World, and it tells you that the time it takes varies inversely with his average speed. So let's think about this. If you drive faster, it doesn't take as long. That seems like pretty practical application, right? When you drive faster, it doesn't take as long. If you drive slower to go to the same place, then it's going to take longer. So speed increases, time would decrease. So here, we don't know how far away he is, but they're telling us it would take 10.8 hours at 50 miles per hour. But what if he drove 60 miles per hour? We don't know how long that would take. So we multiply those two. I get 540 is 60x, and then I divide, and I find out it would take 9 hours. Another common, it's a physics application, is thinking about a seesaw, also known as a teeter-totter, right? Or a lever. Seesaws or levers, like using a crowbar, for instance, or even an Allen wrench is a simple lever. When you're doing that, the force times the distance. The force we'll call it weight. The first weight times its distance has to equal the second weight times its distance. So if I weigh 200 pounds and I sit 3 feet away, if I want to balance with someone who only weighs 100 pounds, I want to know how far away do they sit. That's their distance. That would be 600 is equal to 100 times a distance. And then I divide, and they would have to sit 6 feet away. So my weight times my distance to the middle is going to equal their weight times their distance to the middle. All right, so hopefully that gives you some examples that are pretty similar. Just remember, when you're trying to decide if it's inverse or direct, if it's direct, if the y gets bigger, the x is going to get bigger. If it's inverse, one number gets bigger, the other one's going to get smaller. And then, so hopefully, again, these examples will help. If you set it up the wrong way and get an answer, if you read that answer back in your question, like if you think about it in the situation, then you're probably going to realize that that doesn't seem reasonable. So don't discount your common sense. Oh, and one other thing that I'm going to add, and that is there was one IXL lesson that we used, and that is R2. We did not end up doing R1 because it threw just every imaginable fraction, and while I can handle those quite well, it kind of took away from what I wanted you to get from that lesson. And so hold on a second and I'll be back with R2, which is about writing inverse equations. All right, so this is R2 on inverse equations, and you may be asked to write an equation or you may be asked to find something that's missing. So if you remember in the notes, I told you that one of the ways, what I think is the easiest way to write an inverse equation is to say that x times y equals k. K is just some number. So here, x times y equals, well, in this case, 3 times 3 is 9. So x times y is equal to 9. So x, y equals 9. Now, you could also have written that as y equals 9 divided by x. That's the same thing. So, here we go. X times y, so xy, I can type x times y equals every time this asks me for an equation. 1 times 8 is 8. xy is equal to 3 times 3 is 9. xy is equal to 2 times 8 is 16. It's also less keystrokes to type that in than to use the fraction. xy is equal to 3 times 7.6, so 21 plus 1.8, 22.8. So even when the numbers start looking more complicated, you are still just multiplying them together to get k. See, 9.6 plus 24, 33.6. So more of the same with a decimal. We already did a couple decimals. Now we get one. Now we're not writing an equation. It says write and solve, but we can just do this pretty easily. So what does my first x and y give me? 2 times 6. 2 times 6 has to equal y times 3. So 2 times 6 is 12. So 12 divided by 3 is 4. So very simply, you can multiply the first x and y they give you together and then divide it by the last one. So 4 times negative 12 is negative 48. Negative 48 divided by 3. These two are getting multiplied. So remember x times y, right? So this would be negative 48. So this answer has to also be negative 48. So 3 times y. So when I divide negative 48 by 3, I get negative 16. So suddenly now we have ordered pairs. But remember, ordered pairs, what are they? Ordered pairs are just an x and a y and another x and a y, even though they called that n. So multiply the first ordered pair together. That gives me 4. So 4 has to equal 1 times n. So 4 divided by 1 is 4. So you might feel like, oh wow, we just took all the mystery out of that, right? So 3 times negative 3 is negative 9, divided by 1 is negative 9. 4 times 3 is 12. 12 divided by 12 is 1. Notice that my process, I'm looking for x now, it's still the same. I still multiply the first two together, divide by the guy who doesn't know his partner. 3 times 2 is 6, right? So the two that are together, 3 times 2 is 6, divided by this 6 is 1. I wasn't trying to do that. All right, so hopefully that helps you. Again, that should also, the notes, including the additional things that I talked about, should also help you with the Google Classroom assignment.